Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're gonna talk about good fuel. So let's dive right into it. Now, what exactly makes a fuel good? Basically, what is fuel? Fuel is portable format of energy, meaning you are making it at one point in time. Basically, like for example, in case of nuclear, they are generally made in hypernovas and supernovas, those like heavy elements, and then you split them and you extract the energy. That's one way of doing it. Everything else generally is solar energy, one way or the another. So when you are talking about fuel, like let's say fossil fuel, you are talking about the solar energy that was trapped by plants, made into a physical material like a hydrocarbon, and then it was trapped underground. So that's all there is to it, portable format of energy. Now it must be, basically a good fuel must be transferable, meaning you can take it from point A to point B in a can or whatever have you. It should be portable and easy, and then it should be storable, meaning you can put it and you can forget about it. Again, it's not necessary that you can forget about it like for hundreds of years, but it would be nice if it can. Like basically it should not be like in a scenario where it's like I put the energy here, but over time it start to leak out. That's not good, that's not acceptable. So it has to be storable also, and it should be safe and stable in situations, meaning again, nothing you can make that can carry energy will be safe inherently. It won't be, because it has energy, it can go boom because it has the energy. So it has to be safe enough where it's like, you looked at it wrong and it went boom. You have to be mindful of. Basically it should not be like I sneeze, somebody through a cigarette, is like that should not happen. So that's the whole point here that we want to achieve. Basically it should be safe and stable in situations, and it should be easy to use in different scale. That matters a lot, meaning our power requirement changes, meaning you may want something like tiny puppy, like 5 horsepower, or you may be like big boy. Now this big boy can go up to like few megawatts, or like almost 100 megawatt kind of power rating. So you get that point. Like we have scale requirements, so you can have a like 5 horsepower, 500 horsepower, 5000 horsepower. You get the point. Like all scale should be possible to do with, and it should be cost effective. And nobody got time for environment, nobody cares about it. If you can make your alternate technology cheaper, people will do it. As simple as that. At the end of the day, that's all it boils down to. You cannot replace an old technology with a new one if it's more expensive. It has to be cost effective. So that's what makes a fuel good. So what is the perfect fuel? The closest aspect to perfect fuel, that is diesel at this point in time. Now diesels are generally classified as kind of heavy hydrocarbons. They start from C10, as in like C10H20, to C15H28. Now it can go even higher than that like basically if you start to exceed C15 and you end up in like C20 territory, they are classified as kerosene or jet fuel. And jet fuel is a bit harder to burn. It's like it has a bit more oomph to it, but it does have a consequence. Like it's not that easy to use, so to say. Now if you are familiar with road vehicles, you know for a fact that both engines generally come in like small sizes and large sizes, and generally petrol engines are 5 to 10% less efficient compared to diesel. So this puppy has inherent efficiency advantages, and the moment you start to make big engines, slower rpm, you can achieve something that is unimaginable, almost 54% efficiency in real world use cases. Let that sink in. 54%. Like let's be realistic, petrol vehicles that you are driving will barely give you 20%. This puppy cracks 50%, and at huge scale, not just like some small lab scale. This is some big boy. So that's one of those things that you have to understand. Diesel is inherently efficient by design, because again it achieves much higher compression, so it gets much cleaner burn, everything, and it has more energy there. So it's like really good design wise. It's really good. We can achieve amazing things with it, and it's much harder to ignite accidentally. That also is a very important factor, meaning basically if you take a match and directly put it in a gas, like diesel, you dip it down there, it's gonna put it out. But if you even touch gasoline, you're just like it burns. Why? Because of the what we call flash point. Basically at what point it can ignite. That is very fragile on basic gasoline. It barely needs any vapor pressure. It's just like touch it, cigarette. The moment you talk about diesel, again it will catch on fire. Be mindful, meaning if you send a a lit match there, it will not burn into. Again, if you dip it, it will put it out. It may even act as a fire retardant at that point in time. However, if you let it boil for a certain while, basically reach around 50 degrees Celsius, yeah, at that point it will catch fire. So again, you get that point. Like compared to gasoline, diesel is far more stable. To give you a context what kind of stability we are talking about, I've seen many woodworkers, when they are cutting wood, they need some lubrication on the basically blades that are like just bandsaw, basically the big ass bandsaw they use. They are using diesel to lubricate it. Let that sink in. There is heat there, there is wood there, and they are using diesel as lubrication, and somehow it's not all catching on fire. That should give you a context. Again, diesel is still something serious, still something to be treated with respect. You should not go YOLO around, diesel tanks. It's one of those things that's like, hope it's safe, but like, it has some tolerance of human error. It's not like achum boom. It does not do that. So that's very good. And it's long-term stable, meaning you can make a tank, you can fill it with diesel and forget about it. And that's another benefit, because if you can technically do that with gasoline, but gasoline evaporates way damn quickly. And it also has quick transfer, meaning you can quote unquote fill up your tank as quickly as you can pump it. So that's like 2 minutes, 3 minutes. So that's the whole point. Diesel is the perfect fuel. That's why we run our tractors, our locomotives, our basically everything that is important runs on diesel, including submarines. So diesel is one of those things where it's like perfect fuel. Everything that you want to create, it must be able to beat this, and in all front. If it can't beat in all front, people will simply not use it. So let's start with electric vehicle. Now electric vehicle has the advantage of zero exhaust. There is nothing coming out of it at the other end. That's awesome. That means you can use it underwater, you can use it in a cave, you can use it in space. That's awesome. It has 85% efficiency, meaning if you take energy from the grid, how much energy is going into your wheels actually doing the stuff. That's 85%. That's good. That's good. That's good. Not amazing, but be mindful, the reason it's not amazing because energy, while it's staying in the same format, electricity, it is going through way too many things. For example, if you're talking DC fast charging, after transformer steps down the voltage from 11 kV to, let's say, whatever, 420, it has to go through a lot of AC to DC conversion, then piling it up, then managing it, and then going into your charge controller. There it's spending a lot of time where it's making sure the battery temperature is well enough. So total round trip efficiency from point A to point B is around 85%. That's good. However, it does have this weakness. Battery is weak link at this point in time, meaning the lifespan of the batteries are not long term, meaning you can, again, because of our emission standard changing, we keep replacing diesel vehicles, but inherently diesel vehicle can last for century. They are that kind of robust equipment, and that's why container ship engines, they are running at such a low RPM. I was freaked out when I first time heard this. Are you telling me that there is a goddamn engine that runs lower than 500 RPM? Are you serious? That's a thing. There is thing that runs at that low RPM, because I'm dealing with petrol engines, so it's I'm used to first gear is it's already 2500. It's what the hell? Diesel, I'm familiar with 1500 RPM, turbocharged to 3000, but the bigger the engine gets, the lower the RPM, and that's why they last longer. So lifespan wise, if you buy a EV, you do not expect this puppy to work after 50 years. It's not gonna work. Again, diesel will work, but problem is by that time it may be illegal simply because of emission standards, but it will work inherently. So lifespan wise, battery is the weak link. And then comes another problem of energy supply chain. Diesel is super easy to transfer from point A to point B. AC system, again, this infuriates me to no extent. It's for all the goddamn EV manufacturers, especially two-wheelers one, they are what if we ever had our own proprietary garbage, because there is so little garbage in this world that we have to make some more garbage in it. I really genuinely hate that part, and that makes the energy supply chain. Even if, let's say, you have a country that's working their ass off to make sure they are covering every place with solar panels, they're working their ass off for offshore wind farm, they're working their ass off with hydropower plant, with biogas generators, with biomass generators, all of that. They're working their ass off to have something a stable grid that can support the weight. How the heck you take the grid energy to your car? Yeah, because there is no standard. And not to mention, DC fast charging is not something that can be done with every car. Yeah, again, it can be done. It's just good luck, your bank balance will be destroyed because I was shocked when they were talking. Yeah, this is just a DC fast charger, it's $1 million. What the heck? Yeah, it's that expensive. I was also shocked. It was very expensive, ludicrously expensive. And it cannot do long-term storage solution, because this e-rickshaw is becoming the next big thing in India, and it's going all in, and it's running on lead acid battery. However, even though this works, it's profitable. That's why it's spreading everywhere. It's flat or not long-term storage, meaning if you charge this puppy, you had to pay electricity bill for that. You charge this puppy and you're okay, I'm gonna use it after 1 month. Yeah, no. And same goes here. Again, it's much slower, but it's not something that you can expect to work after a year. For example, railway, for many of its diesel locomotive, they shut it down. They're shut it down, bone dry it. But here's the deal. They if tank had let's say 4,000 liter remaining, it will still have 4,000 liter remaining unless somebody stole it. Here, that's not the case. You are constantly losing energy. So if you're talking about big units, you're losing a significant amount of energy. Long term, it's flat out not viable, and it cannot power anything big. That's the big limitation. Again, e-rickshaw does work. It's here, it's real, everything about it is awesome. Electric vehicles, again, it's here, it's real, bit expensive, but close enough where it's because of the war going on, the fuel prices in India is going YOLO. So at this point in time, it might as well be we buy EV because it's cheaper. Again, that's another aspect of it. India had a big reserve of crude oil. Every country does that. Like they try to make sure they have good reserves of fuel there. So crude oil, we like every month you are depositing a little bit. Now because of the ludicrously high price hikes, they are like, what, let's expend some of the deposit. Again, that cannot be done with electrical energy in batteries. Battery will lose the energy on its own. So, and the moment when you are talking about megawatt class, let's say you're talking about a truck, you can't make it. Now you're like, why? Is there a physical limit? Well, no. Problem is there is loss. That means there is some weight constraint on every vehicle. If you have higher weight than that category, you have to pay for higher category, higher taxes. Now, because again, road will be destroyed more. So if your tonnage is limited, let's say it's only limited to 30 tons on a truck, and if your 20 ton is already spent on the battery, what the hell you're gonna carry? That's the problem. That's why. And again, forget about like any big planes, and don't even think about jumbo jets. A380, yeah, that's not happening on electric. That's why electric, while it's a good compromise, is nowhere near as powerful as diesel. Now, what about hydrogen? It's a fuel. So hydrogen, the biggest problem with that puppy is, again, multiple problem, but it has 50% efficiency. Now, 50% efficiency does not sound that bad, but you have to understand, meaning electricity has to come from somewhere. You cannot just like lol electricity. It has to come from somewhere. You have to pay for it. And if you're losing 50% of it, it's gonna hurt. And not to mention 50% is like optimum case scenario. Barely anybody achieves that. Again, because you are changing electricity from different formats. You're changing electricity and making it into hydrogen gas, basically chemical energy. That's why it's so inefficient. Now, it does offer fuel-like refilling, meaning one standard port that works for everything. That's awesome. That's one of the amazing things. Like, there is no supercharging, there is no fast charging. You just quick, done, go home. That's amazing about it. However, hydrogen is one of the worst fuel. Now, simply because every time somebody is like advocating for hydrogen, they are telling you this number. Hydrogen has 120 megajoule per kilogram. GG, absolute truth. But here's the deal, they're gonna tell you gasoline has 43 megajoules per kilogram. Absolutely true. There is no lie here. Here's the deal, kilogram is only telling you half of the story. What about the other half? Other half is this, meaning kilogram, basically megajoule per liter, meaning how the heck you're gonna fill it. So if you take diesel, this puppy touches around 35. That's huge amount of energy per liter. Basically, if you have 1 liter water bottle, you can expect around 35. That's good. Gasoline, basically petroleum, petrol I'm talking about, that's around 32. Good, 32 to 35, that's good, still good. CNG, compressed natural gas, running at 200 bars. You'll be lucky to get around 8. That's low. Liquid hydrogen, that's still lower than CNG. Let that sink in. So basically, if you're getting 9 megajoule per liter, you're gonna get 8. And liquid hydrogen is idiotically difficult to store even for a few minutes. Basically, a rocket have to be fueled, and it's like go. Because from its point of view, liquid oxygen is boiling hot. And because again, this puppy touches almost absolute zero. So it's very difficult, liquid hydrogen. So you really, from a practical point of view, good luck trying to use it in anywhere. Aviation, you can push it, but again, because of the capacity low, and be mindful, kerosene would be even more powerful than this, little bit more powerful, which is like core component of jet fuel. So yeah, not happening. Liquid hydrogen flat out does not have the oomph necessary to do that. Like that's why even in rocket industry we are like, you know what, liquid hydrogen, how about bye-bye, how about we don't deal with you? That's why we are all switching to methane. Now methane here is CNG, but problem is LNG we are talking about. It has a bit higher density. Basically it will be a bit here. And what about pressurized hydrogen, basically hydrogen tanks? What about talking about? If you are pressurizing hydrogen to 700 bar, which is idiotically high pressure, like you generally make 200 bars for CNG, you are expecting the power output of around 5 megajoule per liter, meaning how many liters you have to have. Like the tank has to contain many liters, otherwise it will simply not go far. And if you make cheaper tanks which can store like 350 bars, that's a good luck one to do. That's the whole problem with this. Every Tom, Dick and Harry, we have been trying to make hydrogen car from around 1980s. BMW made it, Audi made it, Honda made it. Every big company has 1 or 2 prototype, or they have actually made a car and actually sold it to public. But all of them always fail to simply catch on to the market because of this main point. And to achieve a scenario where like, this has the same range as petrol car, it has to have very large tanks. Now again, the engineers are very clever about it. They hide it in such a way that you will not notice where the heck there are huge tanks. But at the end of the day, parts count matter, meaning how many things you have to have in your car matters. Now, if you take at a hydrogen car, it's an electric car with extra step. Basically, electric cars with extra step. You are taking basically hydrogen, and because fuel cell do not have instantaneous response, same as like petrol car or diesel car, you cannot just have like I'm gonna open the valve and tada, power. It takes some time. and it may not even have the output that you want. So in those sort of scenarios, battery is used as a buffer. Now here's the deal. What if you throw away the high pressure tank, throw away the fuel cell, which is very expensive, and you just take the battery and you're like, hey, instead of like, let's say 10 kilowatt hour generally they give for like, all things, how about you take that 10 and make it bigger, like 30. Mahindra Evo in India has 50 is generally good for city cars. For long range anxiety kind of people, then you want to push it to 100. But you get the point. Like you already are building a complete EV. How about you throw away extra things and make it simple? That's why hydrogen never works, simply because of this graph. Everybody will tell you like it has 120 megajoule per kilogram. You're like, shut up and tell me how much it has in liters. To give you a context, try googling what was the turbo pump size for space shuttle main engine RS-25. This big. Oxygen tank, oxygen pump, this much, simply because the hydrogen is low density, and that's in liquid format. Compressed gas, yeah, good luck. So this is a reason hydrogen is a bad fuel. So let's talk about this main question here. Now you have to understand, realistically, in all scenarios, no matter what the cost is, there is nothing that beats heavy hydrocarbons. Meaning the moment you start to go into heavy hydrocarbons for energy carrying capacity, nothing beats like, good old diesel. Nothing even comes close to that. Like methane is like, a good compromise, but again, compared to diesel, it's like, bro, no, just no. So in that sort of scenario, you have to understand, nothing beats heavy hydrocarbon. How the heck you get hydrocarbon? You get hydrocarbon by CO2 and sunlight. Now here's the deal. We have abundance of these things. Again, if you're thinking a solar panel can actually do something, think about this, that you are thinking by default that sun is not gonna run out. So you can have CO2, as much CO2 as you want, you can have sunlight, and you can have hydrocarbon. That's the whole point of plant life. That's what plant life does, and that's how we are getting fossil fuel. Only difference is, only mistake we did, rather than making our own, which was originally designed by Rudolf Diesel, yes, the creator of diesel engine. He wanted like basically tractors to run on the basically vegetable oil. And yes, that's why you can literally take vegetable oil, put it in your car, it will work. It will be very expensive, but you can work it, and it will have does not have the same additives, so your injector might get clogged, but on a technical level it will work. So that's the whole point. We can do that. Now a plant does that, but plant is very inefficient, meaning every day how much yield you're gonna get, that's very low. That's not good enough. However, if you go to the microscopic level and you start to utilize algae for that, algae does have the benefit that it's working on a daily basis, rather than like, you plant the crop, you harvest the crop, and then you do that and it takes a few months. Now algae every day. So algae is one of those things that is amazing. And another aspect of it, once you start to use algae for making hydrocarbons, heavy hydrocarbons, specifically biodiesel, you do not have to change anything about our current world. Everything, basically jumbo jets. Yes, there are jumbo jets, be mindful, more or less is the same. So if you can make hydrocarbon heavier, from a chemical point of view, it's not different. Again, additives you still have to add for like, cleaning the injectors and all that jazz, for making sure there is no moisture content. That's up to you. But other than that, inherently on a chemical level is the same, because it's the same chemistry, is the same thing. So you can run a jumbo jet, and people have actually tried it, run jumbo jets, including fighter jet also, because Pentagon was trying very early on that. They did not like it during Gulf War. They did not like the fact that their oil was dependent on someone else. So they wanted to like have an alternate. Now again, engineers figured out how to make the alternate. They were like, can we test it, like actually use it? And yeah, the reality was like it works the same. Again, you have to remove moisture content, because again, it's coming directly from raw, fresh. It's not being cooked under the earth, so it does have a bit higher moisture content, but that's removable. Like we got that, we got the technology. So why the heck we are not doing it everywhere? Reality is, we humans have certain limited amount of neural capacity. We cannot have like infinite amount of ideas processing all the time. Again, I was also the stupid one who was like, hydrogen is the future. And again, I live in a country where transport minister is, hydrogen is the future. I'm like, we have been here from 1970. It does not work. But that's the whole point. If you have bad idea, it keeps good idea out of table. Now another aspect, the worst aspect, is ethanol. Ethanol, because we can make from corn, everybody's like, we should do that. I'm like, why are you wasting goddamn farmable land for the fuel? Again, you should not need that. Like, just go to a desert and just pump water there and just have LG biofuel. And here's the deal. What if you do not have land? For example, in case of India, that we do not have GG amounts of free lands. Okay, awesome, no problem. Okay, that's awesome. Here's the deal. There was engineers also thought of that. What if you do not have access to like, GG amounts of free land? Again, USA has free mostly empty lands, but India does not have that. Canada is like, where are the people? So what can be done? Basically, you can do seaweed. Now seaweed will not be as efficient as basically algae biofuel, but it will be far much better than crops. Crops will take months, seaweed will take weeks, direct algae will take basically days. And seaweed has the benefit, you do not even have to worry about water location, anything. India has ludicrously large basically surface area when it comes to ocean borders. So that's amazing fuel because of the bad garbage ideas like EV. Every Tom Dick and Harry, we want EV. I'm like, do you really want to have EV? Because no EV can even come close to a basic bitch diesel engine, let alone one of the large scale engines. And assume if the same amount of money has been poured into diesel engine and we make high efficiency diesel engines, again, normal diesel engine only gives you like 30% efficiency on road, 28, let's be realistic, but again, still better than petrol. And you will not have any mercury output because again, you are controlling what's going in it. You will not have mercury, you won't have, those sort of contaminants, you won't have sulfur unless you're putting too much here. You can control every single aspect of it. So that's what we have to understand. We have to learn to understand all the sides of it. Meaning, can you transport the fuel? Hydrogen is not good for that. Can you store it for long term? Hydrogen is not good for that. Electric vehicle, really good for small scale, for cheap stuff. But everything else is the only reason EV is even becoming a thing is simply because A, oil is getting more expensive. B, oil is getting really expensive. C, oil is getting idiotically expensive. There is no other reason why EV is even catching on. That's the whole point of it. So either you can invest billions of dollars making something incomplete, that's barely a good compromise, or you can just go here and just like forget about it. It's like, and what about new carbon dioxide release? No, it's the same carbon dioxide that's taking from the atmosphere. Inherently, you're running on sunlight. Inherently, it's a solar energy that has been converted into chemical energy. You do not have to think anything other than that. So these are the main question, and it hurts me to see it's like this sort of amazing technology was there from almost at the end of World War II, and we never utilized this to its full capacity. That's truly tragic. So this was my presentation on what makes a good fuel. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it and enjoyed it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.